Sir, you're muted.
Sir, you're muted. We can't hear you.
All right, it's my bad. I'm just going to repeat it. So you have to explain the principle of the generation and detection of the ultrasound waves. So let me just explain it again. So how we are going to generate the ultrasounds. So while generating the ultrasound, you can see that alternating voltage is being alternate voltage is going to be applied across the piezoelectric crystal, and it is going to create the change in the shape. The alternating potential difference will be causing the crystal to vibrate and to produce the ultrasound waves. The crystal vibrates at the frequency of the alternating potential difference, so crystal must be cut to a specific size in order to produce the resonance. तो ऐसा भी नहीं होना चाहिए कि क्रिस्टल जो है वो बहुत बड़ा हो ताकि वो इतने ज़्यादा वाइब्रेट ही ना कर पाए, या क्रिस्टल इतना छोटा हो कि बहुत ज़्यादा वो वाइब्रेट करना शुरू कर दे. तो वी हैव टू कट इट इनटू स्पेसिफिक साइज so that resonance can occur. And when resonance can occur, when the resonance will occur, so in that specific case what will happen? When resonance will occur, ultrasound will be produced. Ultrasound is going to be produced in that specific case, right? So in the case of generation, this thing happens. The alternating potential difference applied, piezoelectric crystal will vibrate. When it will vibrate, so it is going to produce ultrasound waves. And the crystal should be of such much specific size that resonance should happen to produce the respective ultrasounds. Are you understanding?
Yes, sir.
Hello. And what happens in the case of detection? In the case of detection of the ultrasound waves, so when the ultrasound waves returns, right? When the ultrasound waves are going to return, the crystal vibrates, which produces an alternating potential difference across the crystal. So whenever the ultrasound wave is going to return, when when the ultrasound wave returns, when the ultrasound waves come back, the crystal vibrates and it produces an alternating potential difference across the crystal. And this received signal can then be processed and is used for medical diagnosis. So, whatever the ultrasound signal is going to be returned, it will be converted back into the alternating potential difference, and that alternating potential difference will be processed by the ultrasound machine. So are you understanding how the ultrasound is being generated and how then it is being detected? It is the working of a piezoelectric material which is actually creating this whole functionality. Understanding?
Yes, sir.
Okay. So next is using the ultrasound in the medical imaging. So how are we going to use it actually? So you can see this diagram can tells us an happening of the ultrasound at the moment. So here you can see the ultrasound transducer is being kept on the womb, right? So let's say this is a womb, and on this actually um, an ultrasound transducer is being placed. The ultrasound transducer is going to produce the ultrasound waves. Those ultrasound waves are going to hit that object, the other object inside the body, and then pulses are going to be reflect at the boundaries in the body. And the reflected pulse is then detected by what? It will be detected by the transducer, and those signals, when they are going to be detected by the transducer, will be absorbed by the will be converted back into the electrical signals, and then electrical signals will be processed by the machine and it is going to produce its picture. So I must read what is written here. In an ultrasound scanner, the transducer sends out a beam of sound waves in the body. The sound waves are reflected back to the transducer by boundaries between tissues in the path. So when these echoes hit the transducer, they generate the electrical signals that are sent to the ultrasound scanner. And using the speed of sound and the time of each echo return, the scanner calculates the distance from the transducer to the tissue boundary. These distances can be used to generate two-dimensional images of tissues and organs. So दो चीजें इसमें यूज होती हैं to generate the images. One is कि जो echoes आ रहे होते हैं इलेक्ट्रिक पल्सेस के वो और वो कितनी स्पीड के साथ साउंड जो है वो आ रही है और कितने टाइम में वो जाकर हिट करके वापस आ रही है. सो वो साउंड और वो टाइम दोनों जो है दे आर गोइंग टू बी यूज्ड टू क्रिएट व्हाट, टू क्रिएट द डेप्थ के हाउ मच डीपर द ऑब्जेक्ट इज फॉर इट्स मेडिकल imaging. Is this fine?
Yes, sir.
Okay, this is another example. Before the example, the ultrasound gives two main piece of information about the boundary. Boundary का मतलब क्या है कि let's say if there is a soft tissue and after soft tissues that there is another object is being placed or another object is present. So what sort of information about that boundary between the two mediums we can get. First of all, we can get the information about the depth. और depth का कैसे पता चलेगा? We can get the information about the depth, the time it is taking between the transmission and receiving the pulse. तो कितने टाइम में अल्ट्रासाउंड एंटर हुआ बॉडी में और कितने टाइम में वापस आया, that is going to tell us about the depth of the boundary, how deeper a boundary is. And second thing is about the nature of the boundary. And about the nature of the boundary, amount of transmitted intensity received, कितनी इंटेंसिटी की जो अल्ट्रासाउंड भेजी थी क्या उतनी इंटेंसिटी की अल्ट्रासाउंड वापस आई है या कम की आई है, दैट ऑल्सो टेल्स अस अबाउट द डेप्थ, दैट ऑल्सो टेल्स अस अबाउट द नेचर ऑफ द बाउंड्री. तो डेप्थ हमें पता चलेगा टाइम, रिफ्लेक्शन ऑफ टाइम से, और नेचर का हमें पता चलेगा फ्रॉम द अमाउंट ऑफ इंटेंसिटी रिसीव्ड. So amount of transmitted intensity received is going to tell us about the nature of the wave. Yes, student, is this understandable? So these two information can be received using the ultrasounds about the boundary, about the depth, and about the nature of the boundary, whether the nature of the boundary is like thick or thin or what. The thickness and thinness of the boundary is going to be heard from this nature. Is this fine? In this worked example, what this worked example is saying, explain the main principle behind the use of ultrasound to obtain the diagnostic information about the internal body structure. So what are the main principle behind which the use of ultrasound we need to obtain diagnostic information? तो diagnostic information हमें क्या पता चल सकती है? पहले आप सारा लिखेंगे वही कि pulse of ultrasound is emitted by the piezoelectric crystal. This is reflected from the boundaries between the media. The reflected pulse is detected by the ultrasound transmitter. The signal is then processed and displayed on the screen for the healthcare worker to analyze and use for the medical diagnosis. The intensity of reflection gives information about the nature of the boundary. The intensity of the reflection gives us what? The intensity of the reflection gives information about the nature of the boundary, and the time between transmission and receipt of the pulse gives information about the depth of the boundary. So the intensity of the reflection gives information about the nature of the boundary, The time between transmission and receipt of the pulse gives us information about the depth of the boundary. तो ये दो चीजें हमें information mainly provide कर रही हैं about the diagnosis. कि नेचर ऑफ बाउंड्री हमें किससे पता चलती है? इंटेंसिटी ऑफ रिफ्लेक्टेड वेव से. और कितनी डीपर है कोई भी ऑब्जेक्ट, वो हमें कितना पता चलता है? टाइम बिटवीन ट्रांसमिशन और रिसीवल ऑफ द पल्स से. तो कितने टाइम में वो ट्रांसमिट हो रही है और कितने टाइम में वो रिसीव हो रही है, दैट टाइम डिले इंफॉर्मेशन इज बीइंग नोन फ्रॉम द डेप्थ ऑफ द बाउंड्री. आर यू अंडरस्टैंडिंग? Hello,
Yes, sir.
you have to memorize these wordings for the respective answers in the question. Okay, next is the very important term, and this is the main term which is required in the ultrasound, and this is the ending part of the ultrasound, and it is called as specific acoustic impedance. This is one parameter which is pretty very important, and this is related to the medium, like the medium in which the ultrasound has to cross or has to move. So, specific acoustic impedance, what it actually means, it is a term which is related to any of the medium. So we know कि medium की कोई density भी होती है, ठीक है? Every medium is having some density, और हर मीडियम की कोई ना कोई उसके अंदर कितनी स्पीड से जो है वो साउंड ट्रेवल कर रहा है. So what is acoustic impedance? The acoustic impedance of a medium, it is defined as what? It is defined as the product of the speed of the ultrasound in the medium and the density of the medium, right? What is acoustic impedance of a medium is defined as? The acoustic impedance of a medium will be known as the product of the speed of the ultrasound and the density of the medium. So acoustic impedance is represented by Z, by a letter Z. And what is its formula? Z is equals to, the formula for it is Z is equals to density into density into density into speed of sound in the medium, right? So what is acoustic impedance? Acoustic impedance is actually equals to density multiplied by density of the medium multiplied by speed of the ultrasound. So what is the density with which what is actually the density of a medium is, and next term is the speed of the ultrasound with which it is moving. So C is called as speed, C is called as the speed of ultrasound, and rho is called as density of medium. So density of medium, and C is called as speed of ultrasound. So speed of ultrasound and density of medium, and this product will be equals to acoustic impedance. This will be called as acoustic impedance. So acoustic impedance is equals to density of a medium multiplied by speed of ultrasound. So acoustic impedance Z, this will be equals to density of the material, and C will be called as the speed of the sound in the material. So this equation tells us actually that higher is the density, the greater will be the acoustic impedance. And faster is the ultrasound through the material, the greater will be the acoustic impedance. तो हमें किसी भी मटेरियल की acoustic impedance ज़्यादा चाहिए होगी ताकि आपकी जो इजीली फास्ट साउंड जो है अल्ट्रासाउंड जो उसमें ट्रेवल कर सके. सो दिस इज बिकॉज साउंड ट्रेवल फास्टर इन डेंसर मीडियम, बिकॉज इन डेंसर मीडियम दे आर जनरली, अगर सॉलिड्स की बात करें दे आर मोर डेंसर एंड लिक्विड्स एंड गैसेस आर देयर लेस डेंस. सो इन डेंसर मीडियम्स सॉलिड्स के अंदर क्योंकि पार्टिकल्स आर क्लोज टुगेदर सो दे पास ऑन easily, they move on easily, whereas their speed is less in gases and liquid. So in the case of this is specific acoustic impedance. So how do we find out the specific acoustic impedance of any material? We just simply multiply its density with the speed of ultrasound. So speed of ultrasound will be multiplied with the density of the medium. So density of a medium multiplied by speed of ultrasound will be equals to acoustic impedance. Are you understanding? Yes, student, is
Yes,
the
sir.
concept of specific acoustic impedance. Are you understanding? So the product of the speed of ultrasound in the medium and the density of the medium is known as specific acoustic impedance. Okay, moving onwards. Acoustic impedance, we are just going to see what is happening inside it. So, in the case of acoustic impedance, at the boundary between media of different acoustic impedances, some of the wave energy is reflected and some is transmitted. So, for example, if we talk about our skin, and let's say one of the medium is skin, and the other medium is what? One is skin, and other is, let's say, the bone or inner part of a body. So, what will happen? If there is some ultrasound which is incident on the boundary on the skin, so some of the waves, the ultrasounds, there is a probability that they are going to reflect back. They will not transmit inside the body. वो body के अंदर जा ही नहीं पाएंगी. और जब body के अंदर जा ही नहीं पाएंगी तो obviously ultrasound का क्या हमारे पास वो होगा, कोई कोई भी image उससे form नहीं होगा. तो बहुत ज़रूरी है अल्ट्रासाउंड की प्रॉपर इमेजिंग के लिए कि जो दो मीडियम आपस में इंटरेक्ट कर रहे हैं फॉर, जिसमें अल्ट्रासाउंड ने ट्रेवल करना है, लाइक एयर से स्किन में जाना है या एयर से बॉडी के अंदर जाना है, उन दोनों मीडियम के लिए ज़रूरी है कि उनका क्या सेम होना चाहिए, उनकी एकॉस्टिक इम्पिडेंस शुड बी सेम, देयर एकॉस्टिक इम्पिडेंस शुड बी इक्वल. So at the boundary between media of different acoustic impedances, some of the wave gets reflected and some of them transmitted. अगर acoustic impedance दोनों material की equal होगी, so will be ultrasounds will be fully transmitted. Ultrasounds will be what? Ultrasounds will be fully transmitted. So if the acoustic impedance of both the mediums will be same, the ultrasounds are going to be fully transmitted. So at the boundary between media of different acoustic impedances, some of the wave energy is reflected and some is transmitted. The greater is the difference in acoustic impedance between the two media, the greater will be the reflection and smaller is the transmission. So two materials with the same acoustic impedance would give no reflection. And two materials with a larger difference in values would give much larger reflection. सो फॉर एग्जाम्पल एयर का इम्पिडेंस होता है 400 और स्किन का इम्पिडेंस है हमारे पास 1.7 इंटू 10 पावर 6, तो दोनों की जो इम्पिडेंस है वो सेम नहीं है. तो इट मीन्स देयर इज गोइंग टू बी द रिफ्लेक्शन ऑफ द अल्ट्रासाउंड. अल्ट्रासाउंड वेव्स आएंगी, टकरा कर वापस चली जाएंगी, और जब वो टकरा कर वापस चली जाएंगी, सो इट इज ऑफ नो गुड यूज. So large difference means ultrasound would be significantly reflected. तो इसके लिए हम क्या करते हैं, बॉडी के ऊपर आपने देखा होगा वेन एवर एन अल्ट्रासाउंड इज हैपनिंग ऑफ एनी ऑफ द पेशेंट, they actually apply some gel on the skin, and that gel is called as coupling gel. What that gel do, that coupling gel is having same acoustic impedance as that of the skin. The acoustic impedance of the coupling gel and the acoustic impedance of the skin is same, due to which all of the ultrasound waves are fully or to maximum level they are transmitted. So maximum ultrasounds are going to get transmitted. Are you understanding? So the coupling gel used has a similar Z value to the skin, meaning that very little ultrasound will be reflected. बहुत थोड़ी सी अल्ट्रासाउंड जो है वो रिफ्लेक्ट बैक करेंगी. तो कपलिंग जेल क्या करती है, कपलिंग जेल जो है वो बेसिकली सारों को एक्चुअली ट्रांसमिट करवा देती है इंसिडेंट अल्ट्रासाउंड्स और reflected ultrasounds को. Yes, people, are you understanding about this fact?
Yes, sir.
Okay. So moving onwards next, so here we can see this. This is a very basic example. The table shows the speed of sound, acoustic impedance in four different materials. So there are four different materials: air, gel, soft tissue, and bone. And each of them are having different speed. The speed of ultrasound is 330, 1500, 1600, 4100, and the acoustic impedance for each is being shown as well: 4.3, 1.5, 1.6, 7. So question says use this to calculate the value for the density of a bone. तो आपने bone की density निकालनी है. So how are you going to find out the density of a bone? So formula हमारे पास क्या है? Acoustic impedance divided by speed. So acoustic impedance हमारे पास कितनी है? 7 into 10 power 6, और speed हमारे पास कितनी है? 4100. तो हमारे पास bone की density आ जाएगी. So density of the bone will be kg per cubic meter. So density of a bone will be 1700 kg per cubic meter. Yes, student, are you understanding how to find out the acoustic impedance? Using the acoustic impedance for finding the density of respective thing. So you have to keep this formula in your mind. This will not be given into your formula sheet. That acoustic impedance is equals to density into speed of ultrasound. The speed of ultrasound being multiplied with the density is equals to acoustic impedance. Is it fine?
Yes, sir.
Okay, there is another important phenomena, and what this phenomena is, it is called as intensity reflection coefficient. So, in the case of ultrasounds, there is another coefficient present, and this coefficient is very, very important to be understood. So, what this coefficient is, it is the ratio of the intensity of the reflected wave relative to the intensity of the transmitted wave. For example, if we are having two medium, so let's say one of the medium is air and the other medium is your skin, right? So ultrasounds are being trying to push into it, and the ultrasounds are going to move this way. So these are the incident ultrasounds, and these are the transmitted ultrasounds, right? And some of the ultrasounds are going to reflect back if their impedance, if the impedance of hair and skin is not going to match. So some of them are going to get reflected. They are going to bounce back. So what will happen? The intensity with which they are incident, let's say this intensity is called as I naught, and the intensity with which they are reflected inside, they are called as IT, the transmitted ones, and the ones with which they are getting back into the medium, its intensity is called as IR, right? So intensity, the total incident intensity is equals to IT plus of IR. The total intensity, the total intensity of the reflected, or so the total intensity of the ultrasound is equals to the transmitted intensity plus the reflected intensity. So some are going to get transmit, and some of them are going to reflect back. So what is the intensity reflection coefficient is? That how much this coefficient tells us how much of the intensity of the ultrasound is going to bounce back. So it is given by what formula? Alpha is equals to IR divided by I naught. Alpha is equals to IR divided by I naught. So what is IR? IR is the reflected intensity, and what is I naught? It is the transmitted intensity. और इसका formula क्या है? Alpha is given by the formula. So let's say the impedance of second medium minus impedance of first medium square whole divided by impedance of second medium plus impedance of first medium whole square. So taking the square of the difference of both the impedances divided by taking the square of the sum of both the impedances, this is equals to what? This is equals to intensity reflection coefficient alpha. This is equals to intensity reflection coefficient alpha. So intensity reflection coefficient alpha is equals to Z2 minus Z1 whole square, which is equals to Z2 plus Z1 whole of square. So the ratio of the intensity of the reflected wave relative to the incident wave is known as alpha. Yes, student, is this fine? So alpha is the intensity reflection coefficient, IR is the intensity of the reflected wave, I naught is the intensity of the incident wave, Z1 is the acoustic impedance of one material, Z2 is the acoustic impedance of the second material. So you would be having the data sheet, you will be provided with the data sheet in your exams about this equation. So what does this ratio shows? That if there's a larger difference between the impedance of the two materials, the most of the energy will be reflected. And if the impedance is same, so all of the ultrasound will be transmitted. There will be no reflection. There is going to be no reflection inside it. Are you understanding?
Yes, sir.
Density of the reflection coefficient. Okay, so next is coupling medium. So to match the acoustic impedance, to match the acoustic impedance of two medium, to match the acoustic impedance of two medium, we use we use coupling medium, right? To match the acoustic impedance of two medium, if we have to match the acoustic impedance of the two medium, we will use the coupling medium. We are going to use the coupling medium, right? So you have to understand it. What's a coupling medium? To match the acoustic impedance of two medium, we use coupling medium. So when ultrasound is used in medical imaging, a coupler is needed between the transducer and the body. The soft tissues of the body are much dense than the air, तो उनकी density change है तो उनकी acoustic impedance भी change होगी. And if air is present between the transducer and the body, then almost all the ultrasound energy will be reflected. But the coupling gel is placed between the transducer and the body, as skin and coupling gel have same density, so little ultrasound will be reflected. And in this case, majority of the ultrasounds are going to enter into the body for the functionality to be displaced. So in exam में ये सवाल पूछा जाता है, what is the purpose of a coupling medium? Yeah, why a coupling gel is being used before the usage or before the process of ultrasound. So we are using the coupling gel because coupling gel makes the impedance of the skin same to the impedance of the gel. In this way, when the transducer is placed on the gel, there is no air between the transducer and the skin. They have same impedance, so maximum of the ultrasounds are going to get transmit inside the body. तो majority of the ultrasound जो है वो सारी की सारी body के अंदर transmit हो जाएंगी. This is the purpose why we are using the coupling medium or coupling gels for the transmission of the ultrasounds. Yes, student, is this understandable?
Yes, sir.
Okay. So this